On May 18, 1980, a catastrophic geologic event occurred that not only shocked the world because of its explosive power, but it also challenged evolution theory at its foundation. That event was the eruption of Mount St. Helens in 1980 in Washington State. I believe that the eruption of Mount St. Helens will be remembered as one of the most significant geologic events of our century. And when people look back on the 20th century and ask what was going on geologically to challenge the dogmatic teaching of evolution in our day, I believe one event is certain to come to people's attention, the eruption of Mount St. Helens. There in Washington State in 1980, in a very real and graphic way, a miniature laboratory was set up for the study of creation and catastrophe theory. In the next few minutes, I'd like to explain a little bit about what the volcanic eruption was like, relive the event by way of slides, the activity that we saw there, the photographic documentation, visit the places we've overflown it with helicopters, that type of thing. Another thing I'd like you to know and understand is a little bit about what the volcano did in very short order. An incredible series of events was set up by this rather small volcanic eruption that challenge our way of thinking. And I'd like to apply what we have seen at Mount St. Helens and what you can see at Mount St. Helens to other geologic features of the Earth. Grand Canyon, Yellowstone, coal layers, that type of thing. Finally, I'd like to explore the implications of Mount St. Helens, what it says to you and me personally about our view of ourselves, view of the way the Earth works, and ultimately our view of God. Well, here's the way I remember Mount St. Helens before the eruption: 9,677 feet tall, a very symmetrical profile volcano. It had to be the most gorgeous place on the surface of the Earth. Absolutely beautiful. Spirit Lake there, directly north of the volcano. Just absolutely gorgeous. Here's what it looked like after the eruption. The volcano lost 1,300 feet of summit elevation on the morning of May 18th as 1/2 cubic mile of landslide material, summit and north slope, slid off the top of the mountain. 1/4 of the landslide material, or 1/8 of a cubic mile, slid down into the Spirit Lake Basin, displacing the water of the lake up to 860 feet above the pre-eruption level. That's right, a wave or series of waves went crashing up on the north shore of the lake, 3 football fields high. The lake sloshed back into its new basin with a dam at the southwest corner, showing us this a completely altered terrain. Simultaneously, 3/8 of a cubic mile of landslide material went down to the west, down the Toutle River drainage basin, and blocked that drainage area. The summit and north slope was like a giant cork holding down the volcano, holding down the pressure inside the volcano. As the summit and north slope left on the morning of May 18th, 1980, super hot liquid water inside the volcano flashed to steam, somewhat like a soda pop bottle. You know, when you shake up the bottle with the cap still on the bottle, no fizzing occurs? Well, the same thing, except not carbon dioxide gas, but steam pressure. As the summit left, it released the pressure inside the volcano, and we had this northward directed steam blast equivalent to 20 million tons of TNT blast energy. It did not blow up into the air like volcanoes normally do. It blasted out northward over the landscape, and it leveled 150 square miles of forest in 6 minutes. Enough trees to build 640,000 three-bedroom homes. The northward directed steam blast was one of the most interesting aspects of the 1980 eruption. Here's the old profile, 9,677 feet tall. There's the new profile underneath it, 8,365 feet. It lost 1,300 feet of summit elevation on the morning of May 18th. This would not be the place to be standing on the morning of May 18th. It would ruin your whole day. 1/2 cubic mile of landslide material came directly at us, and then behind that, the steam blast equivalent to 20 million tons of TNT blast energy. Here's the first steam eruption. Remember, it came over the radio in the middle of March 1980. There was an earthquake directly under the mountain, and within a week, it was venting steam. On March 27, 1980, the steam issued from the top of the volcano. Then erupted volcanic ash, and here you see one of the first volcanic ash eruptions in March and April 1980. Here you see one of the last profile shots taken of Mount St. Helens. On the morning of May 18th, this incredible event occurred. During that 3-month period between the middle of March 1980 and the middle of May 1980, geologists had made a dreadful discovery. the north slope of the volcano was swelling at 3 to 5 feet a day. During the last 3 days, May 15, May 16, and May 17, the geologists were making measurements that indicated that the north slope of the volcano was swelling at up to 50 feet a day. 50 feet a day. It would not be inappropriate to say that geologists knew that something was about to happen. Exactly what was a matter of considerable speculation among geologists. Well, you know the story. At 8:32 in the morning on May 18th, at 17 seconds after 8:32, there was a Richter magnitude 5.1 earthquake directly under the summit, which dislodged the summit and north slope of the volcano, and we had this enormous landslide, half cubic mile of material in this landslide, and then the steam blast that followed it. So happens it occurred in broad daylight, not a cloud in the sky, people in airplanes flying over the summit, people on the ground taking pictures of the whole experience. It was one of the most photographically documented transient events of history. Turns out that people were flying over the summit. Here's the summit crater that we saw just before the eruption. Here is the first rock fall evidence in the summit crater, the morning of May 18th. At 8:32, 17 seconds after 8:32, the earthquake energy reached the summit of the mountain. Keith and Dorothy Stoffel in a chartered plane were flying directly over the summit. They were making their third pass. They thought it was their final pass. It was logged to be their final pass. As they flew over the summit, nothing seemed to be happening. And then finally, they saw the rocks falling into the summit crater there at the top of Mount St. Helens at 17 seconds after 8:32 as the earthquake energy reached the summit of the mountain. So happens that Dorothy explained this to me. Dorothy Stoffel explained this to me just recently. She said as she looked down on the north slope of the volcano as the airplane was flying over, they saw something happen that was extraordinary. The whole north slope of the volcano right here began to undulate like the waves of the sea. And then all of a sudden there seemed to be like a zipper opening up from the bottom of the volcano toward the top. The whole north slope began to slide, and then the steam blast came out of the volcano. Here you see the steam blast as it's occurring. The airplane, fortunately, was not flying north over the north slope of the volcano. It was flying from west to east over the north slope. Here we are looking back to the west over the north slope of the volcano. The landslide, the north slope has already slid away, and here's the beginning of the steam blast, equivalent to 20 million tons of TNT blast energy. Not going up, but northward over the landscape. On the ground, a geologist named Keith Ronholm was taking these photographs 10 miles northeast of the volcano. 10 miles northeast of the volcano, a place called Bear Meadows. And Keith Ronholm had these cameras on his tripod, and he clicked this picture. The airplane is up there in the upper left-hand corner, invisible at the 10-mile distance. But here you see the beginning of the steam blast. The landslide has already left and is on the other side of that ridge, that first ridge right there, and the wave is occurring in the lake. Here's the second ridge, and he is standing on the third ridge, northeast of the volcano. One of the next photographs taken, here's the steam blast as it's occurring, the 20 million tons of TNT blast energy issuing out. This is a ground-hugging slurry of volcanic ash and steam. Inside that cloud, it's 550 degrees Fahrenheit, and it's moving at 200 miles per hour there. And it's a hurricane velocity cloud. And inside of there, it's extremely hot. Here's the steam blast cloud coming over the second ridge, approaching Mr. Ronholm where he was taking those photographs. Here it is coming over the second ridge. And this is a ground-hugging cloud of volcanic ash and steam that is toppling the forest as it goes. Right about this time, Mr. Ronholm, who was taking these pictures, made a very important decision. He said to himself, this steam blast cloud seems to be coming directly at me, but not wishing to miss any of this experience and record for posterity this event, he took this next photograph of the steam blast cloud coming over the top of where he was located. Incredible event happened. That third ridge that he was standing on deflected the momentum of the steam blast cloud up over the top of him. As this next photograph shows, it rose over the top of him. Before it could fall back to the ground and smother him, moving at great speed down this logging road, he was able to get some distance between him and the cloud and even tell the story and trade his slides of the adventure that he experienced. The weather satellite on the morning of May 18th was taking these photographs. This was taken at 9:15, so this would be 43 minutes after the explosion. The weather satellite from 22,000 miles in space took this photograph, and you can see the donut-shaped cloud around Mount St. Helens. That's the atmospheric effects of the 20 million ton TNT equivalent blast energy moving out. The afternoon of May 18th, you see the steam blast cloud, the volcanic eruption all over eastern Washington state. You can see the volcanic ash in the atmosphere, northern Idaho, and even into western Montana. There were very significant volcanic ash clouds given off by Mount St. Helens. This is Yakima, Washington, about noontime on May 18th. It got so dark just a few minutes later that the street lights automatically turned on. It got pitch black at noon underneath the volcanic ash cloud. Then it erupted very violently. For 9 hours, Mount St. Helens built this enormous plume of volcanic ash which stood over the summit. During that 9-hour eruption, the volcano released the energy equivalent of 400 million tons of TNT blast energy. 400 million tons of TNT blast energy is equivalent to 30,000 Hiroshima-sized atomic bombs. Since there's 33,000 seconds in 9 hours, that's the equivalent of an atomic bomb a second. That's the power output of the volcano in full eruption. Yet Mount St. Helens is just a small to average volcano from the standpoint of human experience in history. There have been a lot bigger volcanic eruptions. They came back the day after, and it looked like the moon. North of the volcano, the ground was covered with volcanic ash, 500 degrees Fahrenheit. You need special shoes just to walk on the ground surface. Part of the forest north of the volcano. This area was leveled by the steam blast. It took less than a minute for the steam blast cloud to move completely through the field of view. It toppled the forest. It looks like toothpicks strewn around the landscape, but that was a mature forest that was devastated by the blast. A total of 57 people died as a result of the eruption. All were warned or had gone beyond barricades or in areas where there was reason to believe that there was severe geologic hazard. These people died with a warning. And here, the two died here at the camper. Probably the most famous person to die at the volcano was Harry Truman, not the president, but a man of the same name. Harry Truman, 80 years old, lived there at the South Shore Spirit Lake, directly north of the summit of Mount St. Helens. Here he is in his lodge. Before the eruption, the government authorities came to him and said that he needed to leave because it's a very high hazard area. But he refused to heed the warning. He did not leave. And he was buried under 100 feet of landslide material, another 100 feet of volcanic ash there at the South Shore Spirit Lake. He did not leave, and there was eminent reason to believe that there was an eruption that was going to occur. This was a late model Pontiac Grand Prix that was located a mile or so toward the volcano on the other side of that ridge from where Mr. Ronholm was taking those photographs. And this car was hit by the force of the steam blast. We believe it was thrown across a road about 200 feet. The top was bashed in. A tree fell across the trunk. Everything rubber or plastic inside, the dashboard, the steering wheel, the seat covers, was vaporized because of the high, intense heat. And the tires, they did not burn because they're heat treated, they did not vaporize, but they popped because of the high air pressure, and the paint job didn't come through too well either. Mud flows. On 6 major rivers downstream from Mount St. Helens, we had very severe mud flows. There was more dollar damage from the mud flows than from the steam blast itself. Incredible damage, even far away from the volcano in areas where people thought they would be safe from volcanic eruption. They had these very severe mud flows. This logging camp was overcome by the force of the mud. Very severe mud flows. It looks like a kid's toy box, but that was a real logging camp that the mud came through. Here you see this valley was filled up to this level in mud. 30 feet deep, the mud was flowing through this valley. It scoured the whole valley down to bedrock, and then as the mud flow subsided, it deposited 15 feet of mud. How deep was the mud? Well, you go to the edge of this valley, and you can see the trees along the edge of the valley. You can see the bathtub ring, the mud, how deep the mud got. Can you imagine that? A quarter mile wide of mud flowing through there, 30 feet deep. Very severe hazard and damage from mud flows. The crater itself has been the subject of intense study. And here you see the way the the crater at Mount St. Helens appears these days. You notice we have this enormous mushroom-shaped gob of rock which sits in the neck of the volcano. It's kind of a cork holding down the pressure. It's like toothpaste which is squeezed out of the neck of the tube of toothpaste. Molten material in the neck of the volcano has been squeezing up there and into that dome-like structure, and as it cracks and steams, molten material cools in the cracks and it forms this enormous structure called a lava dome. It's about 1,000 feet high, a couple thousand feet in diameter, and it's the cork holding down the pressure in the neck of the volcano. Here we are looking down on the lava dome. You can see it's an awardee type of appearance. That's one of the earlier lava domes. There's been 6 lava domes that have been built up since 1980. That's an earlier one that was kicked out of there by a subsequent volcanic eruption. It has that awardee type of appearance. We're looking directly down on the lava dome from above, and you can see hot rock in places can be seen in the cracks of the lava dome itself. Very interesting the way molten material has been injected into those cracks in the lava dome itself. We've been able to go into the lava dome, and it's not the favorite type of tour that you want to take. Here it is, this enormous dome structure, over 30-story tall building in height. It continues to steam and crack. There were no lava flows from the recent eruptions of Mount St. Helens, just dome building and dome cracking events as molten material was injected into the structure itself. The lake north of Mount St. Helens, Spirit Lake, has been devastated by that landslide debris that went in the lake. Here we are looking at the lake. It might appear like it's a beach with logs on it, but that's a lake. That's lake water. You can see water between the logs in the lake. And this is the area of the lake. About 4 square mile area lake, about 2 square miles of it is covered with logs. It's been estimated there was originally about 1 million logs floating in the lake after the eruption. This log mat drifts around. Here you see some of the details of the logs in the water from up above by helicopter. Incredible thing about this log mat is it drifts around. Here you see the log mat, and on one morning I came and photographed it. Notice the peninsula and the cove in this lake. I came back 2 hours later after the wind had shifted, and you can see what happened. The wind blew the logs back to the south in toward the crater, and here you see the peninsula, and there's the cove, and the logs are all over this area. The water is alternately covered with logs as the wind blows the logs around through the lake. Here's the north end of the lake right here. It's a very log-covered area, and you can see here where the wave went. There was a wave 860 feet high, a wave or series of waves 3 football fields high, went crashing up onto that area, and it scoured it of logs, and the logs landed back in the lake. That's where the trees came from that form the log mat these days on Spirit Lake. In the middle of the picture here, this bench was scoured by the wave that came up here in a giant vortex. The foreground was not scoured by the wave, just hit by the blast. Well, this area of Mount St. Helens, north of Mount St. Helens, was a site of intense geologic activity. Up to 600 feet of strata formed here at this location. 600 feet of strata is hard to believe, but since 1980, since May 18, 1980, up to 600 feet of deposits have formed here, and this area has been eroded since then to show us some of the 600 feet of deposits that have formed here. What is amazing is the minute layering that formed in some of these deposits. We have historic observation and eyewitness reports and photographs of this area repeatedly between the eruptions, showing us the sequence of which these deposits formed. Each layer has a date, and I'm fascinated as I study these layers because each layer represents a geologic catastrophe formed since 1980. The one that comes to my mind most vividly here is behind us. We see this layered June 12th, 1980 pumice flow deposit. Hurricane velocity surging flows from the crater of Mount St. Helens came surging down right over this area. In a matter of hours, deposited 25 feet in thickness of strata and minutely layered strata. I had thought that a volcanic eruption would form a homogenized series of deposits. Boy, was I wrong. Here these flows moving at twice freeway speed through this area deposited this minutely layered deposit. There are mud flow deposits here. There is the 9-hour eruption deposit from the 9-hour eruption on May 18th. There's all kinds of interesting features. This is a wonderland for geologists to study. If you were here watching the June 12th, 1980 pumice flow deposit form, you'd be dead. Okay, it was that hazardous of an environment. Nobody actually saw the individual layers form. Underneath this ground-hugging cloud of volcanic ash and steam, I suppose, this layer formed. We believe it took minutes for individual layers to form. Perhaps pulses. The eruption occurred in pulses, and this material came sliding down through this area. And that's how we got each of these layers. I had thought that a catastrophe would homogenize things, and I had thought that layers form slowly and gradually, like between wet years and dry years, or between summer and winter, and the boundary between two adjacent strata would represent long periods of inactivity, perhaps hundreds of years of nothing going on. Boy, was I wrong. Look at this. 25 feet of layers formed in just a matter of hours here at the volcano. Not only did we have lake erosion, but we had very severe canyon erosion. I was able to go up near the crater, and on several occasions I got into these new canyons. We had eyewitness reports and photographic documentation that these canyons were not there before the eruption. This canyon was eroded through solid rock over 100 feet deep after the summer of 1980 by some mysterious agent. There's an ancient lava flow, an ancient volcanic landslide deposit, an ancient volcanic ash layer. All those were gouged out mysteriously by some mysterious agent after the summer of 1980. This helicopter shot shows one of these canyons. An incredible new canyon system has formed right there through solid rock. You can see the waterfall coming in to the canyon, the stream flowing through there. Again, solid rock was gouged out by catastrophic agents. If I had not known about Mount St. Helens and I'd ventured on this canyon, I might assume that canyon was formed one sand grain at a time as it was eroded slowly by that stream. That's the way it might appear, but we have the documentation that this canyon was opened up rapidly and formed by catastrophic agents, not by slow and gradual agents over enormous periods of time. There were secondary steam explosions at Mount St. Helens. Here we see steam jetting to the surface. Large masses of glacier ice from the summit of Mount St. Helens were buried under 550 degree Fahrenheit volcanic ash. And what happens when you bury ice under something so hot? Well, within days, it was venting to the surface and jetting as steam, reaming these enormous steam explosion pits. Here we see the southwest corner of Spirit Lake and one of the steam explosions in progress. This is the largest steam explosion pit, also near the southwest corner of Spirit Lake. Steam is reaming a hole to the surface, and this pit is 125 feet deep, 2,300 feet long, 1,000 feet wide. It was all reamed by steam 5 days after May 18th. This is a photograph on May 23rd, 1980. And this enormous pit has some very interesting sculpture along the north lip of the pit right here. Within 5 days, a very elaborate gully and rill topography had formed. Here's the photograph that was taken of that pit from reverse angle on June 18th, 1980. 1 month after May 18th, the steaming has stopped. We have about 25 feet of deposits in the bottom of the pit, and we see 100 feet of relief from the top of the pit to the bottom of the pit, and we see this gully and rill topography. Reminds me of the Badlands of South Dakota, or the desert terrain in the southwestern United States. I've been accustomed to thinking of that as occurring slowly from gradual rill and gully erosion over hundreds or thousands of years, something like that, and yet here it is. It all formed very rapidly within 5 days, not by water erosion at all, but by gravity collapsing the lip of the pit. The valley of the Toutle River, the North Fork of the Toutle River, was blocked by landslide material. For 2 years it laid blocked by about 3/8 of a cubic mile of landslide material. It was unblocked by a mud flow on March 19th, 1982. A giant mud flow from a lake behind the lava dome in Mount St. Helens came down over this area. This mud flow gouged out the dam and breached the dam, and as a result, a whole new series of channels were cut, and the upper part of the drainage basin of the Toutle River was established into the Spirit Lake area. For 2 years, there was no outlet for Spirit Lake, and the whole upper drainage basin of the Toutle River was isolated from the Pacific Ocean. It was unblocked on March 19th, 1982 by mud flow. This mud flow caused very severe damage. From the air, you can see this, where this breach occurred. The mud came down through here, breached through that dam, and made a whole branching tree-like drainage pattern of incredible complexity. Now, I had thought that a branching tree-like pattern of drainages would be established by streams slowly eating their way headward up into the upland area. It didn't happen that way at all. It happened rapidly by this mud flow event. A whole series of canyons, 5 canyons, come together here. Some of those canyons over 100 feet deep. Incredible complexity of these canyons. Something amazing has happened here as we overlook this area. As we look at these canyons, we see some amazing features. The north area is flat. Then we have the canyon, the cup-shaped side canyons, the gully-headed side canyons. We have the profile of the breach. It didn't occur straight through. It has a kind of a snaky path. All of these things remind us of the Grand Canyon, ultimately. We're looking at a miniature Grand Canyon, 1/40th scale model of the real Grand Canyon. All of this was gouged out essentially in 1 day. The drainage lines were established by the mud flow on March 19th, 1982. Here's the right canyon in those earlier photographs, and you can see over 200 feet wide, over 100 feet high cliff here. We see the stream running down through it. It might appear that that stream eroded that canyon 1 sand grain at a time, but that's not the case. And you can see why this canyon is like that. Notice this enormous basin up above. As I was thinking about this, my normal way of thinking is that canyons are caused by erosion from streams. As I was thinking about this, the canyon caused the stream, not the stream caused the canyon. Here we have this enormous drainage basin. It collects the water, and so that's why that stream is in there. It's trapped. It's a monument, a relic, a leftover feature which formed in the past, which now is not being formed, or not at the same way as it was in the past. Catastrophic geologic agents formed that very severe erosion. There's a man right there at the top of that cliff for scale, 140-foot tall cliff. Do you think that this stream flowing at that rate over thousands of years, perhaps tens of thousands of years, eroded that feature? It might appear that way, but we have the eyewitness reports and the photographic documentation that that's not the case. And it reminds us ultimately of the Grand Canyon. But geologists have been mystified by the Grand Canyon. Most geologists who know about the geology of northern Arizona have junked the idea that the Colorado River cut the Grand Canyon. That's right. It may sound like heresy. The textbooks tell us that the Colorado River cut the Grand Canyon, but the geologists who really know about Grand Canyon area have, for a while now, pretty much given up on that explanation. What caused the Grand Canyon? This satellite photograph of Grand Canyon shows the uplifted plateau land in northern Arizona. And notice the Grand Canyon is positioned through this uplifted, upwarped plateau. The green area here on the north rim of Grand Canyon is a forest. It actually photographs red in the false color Landsat photograph. It's about 8,000 to 9,000 feet above sea level. And here we see the south rim of Grand Canyon. They're about 7,000 feet above sea level. And the Colorado River and the Grand Canyon positioned through that upwarped terrain. How is it that the canyon is positioned there? An incredible problem for the study of the drainage basin of the Colorado River. Many geologists are suspecting that this is an enormous breach dam. that there was some type of rapid catastrophic breaching event from lakes, perhaps, that were to the north and to the east of Grand Canyon. Much like mud came down out of Mount St. Helens, water overtopped the dam, and we have a broken dam, and we might be looking at spillway erosion from this catastrophically drained lake or series of lakes that form Grand Canyon. There was a man who lived 150 years ago in England. He sailed south through the Atlantic Ocean in a ship, and his ship pulled in southern Argentina, and he saw the valley of the Santa Cruz River in southern Argentina, and he thought to himself, my, what a small stream and what a big canyon. And he wrote this in his journal. He said this about the canyon of the Santa Cruz River in southern Argentina. The river, though it has so little power in transporting even inconsiderable fragments, yet in the lapse of ages might produce, by its gradual erosion, an effect of which it is difficult to judge the amount. And he went on to sketch this as he observed the canyon of the Santa Cruz River. He thought of the small, minor power of the river, and then he thought of the lapse of ages which might produce, by this gradual erosion, an effect of which it's difficult to judge the amount. He was thinking in terms of geological gradualism and geological time. In other words, he was thinking as a geological evolutionist, if you will. This man got back into his ship, and his ship sailed into the Pacific Ocean, and he pulled into the Galapagos Islands. And he saw the finches and the reptiles in the Galapagos Islands, and he added the next element to his theory. Not only geological slowness and geological time, but biological slowness and biological time. And he thought to himself, the finches and the reptiles on the Galapagos Islands have been in the state of evolution. And he proposed that natural selection and survival of the fittest gave rise to the diversity of species that we see today on the Galapagos Islands. His name? Charles Darwin. He went on to write the book Origin of Species by Means of Natural Selection. He got his ideas of biological evolution from looking at the finches and the reptiles on the Galapagos Islands, very definitely. But he got his ideas of geological evolution, on which he based his biological theory, from thinking about the Santa Cruz River Valley in southern Argentina. Geologists have studied the Santa Cruz River Valley in southern Argentina and have pretty much come away with the thought that it wasn't eroded slowly over immense periods of time. There's evidence of catastrophic drainage of glaciers upstream from this area. And a number of geological facts suggest that slow and gradual erosion hasn't been the way the canyon of the Santa Cruz River was eroded. Darwin was wrong about his geological theory of evolution. Could he also be wrong about his biological theory? He based so much of his thinking on that foundational idea of slow and gradual erosion by rivers. Well, I was sitting down next to Spirit Lake one day eating my lunch, contemplating the forces of volcanic power, when what should catch my attention but a whole bunch of sticks floating in the lake. There's some prone floating sticks there. And as I looked, I saw two sticks floating upright. And there you see the two upright floating sticks. They're floating off the bottom. They're not standing on the bottom, and they're floating with an inch or so sticking out. Then I noticed sticks standing upright on the bottom in upright position, but they've landed on the bottom and are standing there. There's another stick standing upright on the bottom, even casting a shadow. And then I noticed a whole bunch of prone sticks laying down flat under the water on the bottom. As I was thinking about the way the sticks float, this fascinated me. Look at those upright floating sticks. The wind blows them over into the edge of the lake and they get grounded. As I was thinking about the way sticks float, a really outrageous idea came to my mind. How about the logs? You know, there are 500,000 logs floating today in Spirit Lake. Could they also go into upright floating position? We have 500,000 floating logs, prone floating logs on Spirit Lake these days. Could they also go into upright floating position? The root end could be weighted down by roots. It's denser wood because it has to bear the weight of the tree above, and so the root end could be heavier and sink, whereas the upper part of the log could float, and the whole log could go into upright floating position, I thought to myself. And then I thought, well, the whole log could become heavier in water and could sink to the bottom, and it could be an upright deposited log on the bottom of the lake, I thought to myself. Then what could happen? Well, I was thinking about it. Well, sedimentation is occurring rapidly in Spirit Lake because erosion is occurring around the lake. So we can have the logs buried in the stratal layers of the bottom of the lake, I thought to myself. The logs drop out at different times and have the root ends buried at different levels, as this diagram suggests. What would happen if we cut through the rock stratal layers of the earth and we saw very beautifully petrified logs in standing position, penetrating vertically through the rock strata layers. We might suppose that each of those layers represents an individual forest. For example, this layer right here might represent, we would suppose, a soil zone. Over hundreds, even thousands of years, mature soil developed. Then a forest grew at that level. And that was later buried, and a second forest grew at this level, and this tree really grew in this place. And as it grew there, it was later buried. More soil formation, maybe even thousands of years later, a third forest grew at this level, and that tree fell over and was somehow buried. And then a fourth forest grew at this level. And when we see repeated levels with upright logs penetrating through the different strata layers, we might assume that we have many forests that have been growing in there over an immense period of time. So this idea about how sticks float in the Spirit Lake and the hypothesis about how logs might float and get buried is an outrageous contradiction to our conventional way of thinking about how logs might be buried in the earth. Well, how would we verify that the logs are floating in upright position? Well, we got a boat into Spirit Lake, and we have a sonar in the boat, and automobile batteries and a sonar towfish that power the sonar. Here you see the sonar towfish. It's a long cigar-shaped object. You lower this over the side of the boat, it sends out the sonar signal and reads the profile of the bottom of the lake. Here's the sonar recorder giving off the paper record, and it's an incredible machine. As it gives off the paper record, we can see the profile of the bottom of the lake. Here we see the sound source position, and then we see open water about 20 or 30 feet below the sonar towfish, and there's the first reflection from the bottom of the lake. And then we're looking out diagonally about 50 yards over the bottom of the lake. Well, as we are studying this, we were amazed because here we see a sonar reflector right here standing off the bottom of the lake, casting an enormous shadow 50 yards long over the bottom. And it's a very narrow type of object, and it's very high, standing off the bottom. We were amazed at this. And this one sonar track length troll through the lake, we see the towfish, we see the water below the towfish, about 50 feet of water or so, and we see a diagonally inclined reflector, and notice the sonar shadow behind it. Here's a very thin, narrow sonar reflector standing off the bottom, and there's the sonar shadow behind it. Here's an immense sonar reflector standing off the bottom, and there seems to be an immense sonar shadow behind it. It even seems to have outflaring root mass. It almost looks like the base of a trunk of a tree just standing there on the bottom of the lake. We were amazed. As we did the sonar survey in 1985 and 86 in Spirit Lake, we were amazed at these sonar records. We estimate that there were 20,000 upright objects on the bottom of Spirit Lake. What would Spirit Lake look like if you drained it? It would look like a forest of trees which have been replanted. Not grown there, but replanted. How would we verify that the sonar is indeed giving us the correct impression of the bottom of the lake? We had to go diving in Spirit Lake and scuba diving. Nobody's been so stupid as to do something like this, so I think we were the first to do this, go diving next to an active volcano. And here I am, there's my diving buddy, and we're getting ready to dive. Notice the logs all around us. Very severe log mass all around us. And at the bottom of the lake, total darkness below 20 feet. Very murky, cold water. And I was able to take some photographs of the bottom of the lake. I'll show those later. There I am. There's my diving buddy, and there's an upright log in the lake, just standing there. There's the volcano in the background for realism. You can see we're over the edge of the lake in one area, and we have these upright floaters just standing there, adding more credibility to this theory about how logs float in upright position. We're starting to see evidence that this hypothesis about how logs may float and get buried is really true. Here you see the underside of the log mat with my underwater camera looking up. We have thousands of tons of logs above us. Here we see an upright floater hanging down, a timber that's floating in upright position from the log mat hanging down. Two more timbers floating there underneath the log mat. As you look down on top of the log mat, you don't see the upright floaters very obviously, but when you go underneath it with the scuba diving, you can see it very obviously. Upright floaters, very obvious. On the bottom of the lake, right where the sonar suggested they'd be, we found upright logs in standing position. We have the upright log here in standing position. Here's the second base of a stump of a tree buried in some type of peat deposit. And then over here we have a third log going off there in the background. I was able to get my diving buddy on one side of one of these logs, and I was on the other. We could not dislodge the log. It was solidly buried in the bottom of the lake. At least 3 feet of sedimentation had occurred around the log. Other logs had just recently dropped in because we could easily tip and sway them. That proves that the logs drop out at different times with the root ends buried at different levels, having the appearance of being multiple forests, which we might assume grew there over immense periods of time, thousands of years. Yet it's all happened in a matter of just a few years there at Mount St. Helens. There's a sign at Yellowstone National Park describing the fossil forests in Specimen Ridge area. And the sign says, across the valleys rise the slopes of Specimen Ridge, but the forest you see there today is only the latest chapter in a remarkable story. Buried within the volcanic rocks that compose the mountain are 27 distinct layers of fossil forest that flourished 50 million years ago. And then the right side of the sign even shows some of the detail about how the logs are buried in upright position. Here you see it. Yellowstone's fossil forests are unique. Many stumps still stand upright in the same sites where they grew millions of years ago. The sign even tells you about the millions of years. Here you see the very beautifully agatized logs there at Yellowstone standing up out of the hill. Natural erosion has removed the volcanic strata from around those upright stumps, and we see them exposed. What more natural theory than this? There's the modern forest growing there today. Here's the ancient forest, or series of forests which grew there millions of years ago. It's been suggested there's 27 distinct levels with upright logs there in Yellowstone at Specimen Ridge, and that's supposed to be proof of enormous periods of time. We're able to dig out the roots of some of these logs. They often terminate abruptly about 3 feet from the base of the trunk. The roots do not taper to a point as roots normally do. That indicates that the trees have been uprooted and redeposited. And we've done studies of the tree rings from logs that buried at different levels. And logs at different levels have a correlating sequence of tree rings indicating that the logs, which now have the root ends fossilized at different levels, grew at the same time, thereby falsifying the petrified forest interpretation and calling into question some of these signs that we see. Well, here at Yellowstone, at Specimen Ridge, supposed to be 27 distinct petrified forests. Each one represents enormous periods of time. The whole thing must represent a colossal period of time, according to evolutionists who have interpreted these to be fossil forests. We are learning that there are other explanations. It has been said that we creationists are ignorant and uninformed because we do not understand that this one cliff in Yellowstone, there's proof positive of millions of years. No flood, millions of years. That's what evolution has been telling us at Yellowstone National Park. Now creationists are going back in and reinterpreting Yellowstone National Park, the fossil forest there, in terms of the examples that we have seen at Mount St. Helens. New ways of thinking have resulted from our studies at Mount St. Helens, challenging the conventional way of thinking about Yellowstone. Well, not only are trees and wood petrified in the earth, but they can be coalified. Under the action of temperature and pressure, buried wood and bark material especially is able to be coalified, and we see coal. Coal is that hard, black, compact rock. As you look at coal, you can see the layering and banding to it. It's very obvious, the layering and banding of many of these coals, and especially abundant in coal is sheets of tree bark. Under the microscope, you can look at these very glassy layers, and you can see the cell structure of wood and even bark tissue. And I've been fascinated with coal. For 25 years, I've been studying coal, and it's incredible what you can see in coal. But the layered appearances of sheets of tree bark that make that laminated or layered appearance of coal has often fascinated me. Take a look at the conventional explanation for the origin of coal. You've heard of it. The idea that the plants build up slowly in a swamp. As peat accumulates, logs fall in, the antiseptic waters of the swamp prevent complete decay, and we build up this thick, spongy layer of peat over thousands of years, hundreds, certainly hundreds, and maybe even thousands of years. We build up the peat deposit. Later on, other sediment, sand or mud, comes in and buries the plant material, what we call peat, and then that is later converted with temperature and pressure to coal. And that's the swamp explanation for the origin of coal. Take a look at a drained swamp deposit along the coast of Nova Scotia. Coastal erosion has drained the swamp, and we see here 4 or 5 feet of peat, which has accumulated over hundreds of years. The coastal erosion has removed the trees and the swamp that's there, and we see this rather black, brown grading into black, coffee grounds to mashed potato-like material, very severely decomposed. And we see large objects that are hanging out of the peat deposit. What are those? Roots. Modern swamp peats are intensely root penetrated and produce this homogenized root penetrated texture. And I was taking a bath one day, contemplating the root penetrated natures of modern peats and the layered sheets of bark that we find very abundantly petrified or coalified in coal beds. And this outrageous idea came to my mind. Call it the floating mat model. If you can imagine the thick sheets of tree bark accumulating underneath a floating log mat, not in a swamp. Here's what I sketched. On the basis of some bathtub modeling, I proposed that logs could float in an ocean, and the logs would rub against one another, and the bark would be peeled off and sink to the bottom and accumulate as a thick layer of peat. Later, the log mat could drift away and other sediment could be deposited on top. I was sketching a theory for the origin of coal, not from a swamp, but from a floating log mat. In July of 1979, I defended my PhD dissertation on the floating mat model for the origin of a coal bed in western Kentucky. There at Pennsylvania State University, I did some studies on coal and proposed that a coal bed in western Kentucky was accumulated underneath a floating log mat. I had no modern example. Well, you know what happened. 10 months after I defended my PhD dissertation, Mount St. Helens exploded and made Spirit Lake into a gigantic bathtub, 4 square mile area bathtub covered with logs. I had to go diving in Spirit Lake to see what the bottom of the lake was like. Here I am. There's my diving buddy. We're getting ready to go diving. And notice something about the logs on the lake. No bark. The bark has been rubbed off. Where's the bark gone? Take a look. We're underneath the log mat. We're looking up. Some of these logs are 6 to 8 feet in diameter. Douglas fir, especially abundant. No bark on those trees. I think you can guess where the bark went. It landed on the bottom. On the bottom of the lake, in many places, we see a thick layer of peat, up to 3 feet thick, dominated by sheets of tree bark. Now, if this was buried under temperature and pressure, it could be converted to coal. We may have seen the first step for the formation of a coal bed. Here we see a sheet of tree bark 2 feet across, laying next to a sheet of tree bark on top of a sheet of tree bark in a peat bed 2 feet thick. If we could bury that under temperature and pressure, the sheets of tree bark would give that layered appearance that's very much like our coal beds. Here's my diving buddy picked up a sheet of tree bark. It's very abundant, not hard to find. About 25% of the bottom of the peat deposit itself is tree bark. As we're looking out obliquely over the bottom of this lake, we have seen something extraordinary develop right here in front of our eyes, a living laboratory for the study of the formation of coal. Can you imagine large masses of plants, of logs, floating in an ocean over the center of Kentucky? That'd make the headlines of every newspaper. A log mat half the size of the state of Kentucky, floating in an ocean, logs rub against one another. Where would the logs come from? How would the ocean get over Kentucky? Trees don't grow in the ocean, and the ocean doesn't belong in Kentucky. What's going on there? Some amazing things to think about. Well, anyway, as I thought about it, it almost brings to mind immediately the flood, a flood model for the origin of coal. The Bible says all the high hills under the whole heaven were covered, including Kentucky. Well, as we've looked at this volcanic eruption, we've seen some very significant things happen. On May 18th, 1980, during that 9-hour eruption, the volcano released the energy equivalent of 400 million tons of TNT blast energy. 20 million tons during the first moments of the eruption, and then following that, a 9-hour eruption, equivalent to 30,000 Hiroshima-sized atomic bombs. Unbelievable. As we look back on it, we are amazed at what happened there. causes me to ask who is in control. You know, the humanist, the person who believes that he is the master of his own destiny and control of everything around him, he is humbled because there is power not under man's control. Somebody else is in control. The Bible tells us who's in control. Psalm 104, verse 32. He touches the mountains and they smoke. God reached down his little finger, touches Mount St. Helens, and there's 400 million tons of TNT in his little finger. That's incredible power. And I think about the colossal power of the volcano. I also think about the smallness of God, not just the bigness of God, but the smallness of God, because a warning went out. No one needed to die at Mount St. Helens. All were warned. They'd gone beyond barricades. Harry Truman didn't need to die. It reminds me of the mercy of God. God is not willing that any should perish, but that all should come to repentance. A warning has gone out. As I think about the volcano, I think about the meekness of God. The Bible says the Lord Jesus Christ, He is the creator of all things. He laid aside that power and He came to earth to serve me at my point of need. He died as a substitutionary atonement for my sin. And then the Bible goes on to say, God has highly exalted Him and given Him back a name, given Him the name above every name. At the name of Jesus, every knee should bow and tongue confess that Jesus Christ is Lord, unto the glory of God the Father. Something of the meekness of God, I think, is kind of obvious to me there at the volcano. And as I think about the volcano, I think about my normal everyday way of thinking. If you would have come to me before the volcanic eruption and said the volcano is going to explode and cause up to 600 feet, even of fine layered deposits to form, I would have got into an argument with you because I thought I knew how layers generally form. Or if you would have come to me before the volcanic eruption and said the volcano is going to explode and cause a miniature Grand Canyon 1/40th scale model to form right in front of us, and even gouge out solid rock 100 feet deep, things like that, I would have got into an argument with you because those things just don't normally escape our attention. Or if you would have come to me before the volcanic eruption and said the volcano is going to cause logs to float on Spirit Lake in upright position, fall to the bottom of the root ends buried at different levels, having the appearance of being multiple forests, which grew there over immense periods of time, I would have thought that you were crazy because those things cannot be conceived in a rational way of thinking. About the only thing I might have agreed with you before the eruption was the notion that peat could be accumulated underneath floating log mats. I was starting to think that way. Floating log mat model and some bathtub experiments and things I was doing seemed to suggest that to me. I learned that God specializes in doing things that I think are impossible right there at the volcano. Some amazing things have happened. How about you? Do you have something in your life you think is impossible? There at the volcano, a challenge for our faith. Well, in the last few minutes we've shared a little bit about what the volcano was like. We've relived the volcanic eruption and the experience that occurred there. We have gone back and we've looked at some of the amazing things the volcano has done in very short order. It's almost a Ripley's Believe It or Not. And then we've gone on and tried to apply what we have learned at Mount St. Helens to other geologic features of the earth, such as Grand Canyon, Yellowstone, coal, that type of thing. And then finally we've thought and contemplated what the volcano says to you and me personally about our view of ourselves and the earth in which we live, and ultimately how the earth works, and our view of God. All these things are of interest at the volcano. I believe that the eruption of Mount St. Helens will be remembered as one of the most significant geologic events of our century. And when people look back on the 20th century and ask what was going on geologically to challenge the dogmatic teaching of evolution, I believe that people will remember this very significant event, the eruption of Mount St. Helens. In a very real and graphic way, we have seen set up before us a miniature laboratory for catastrophe theory, a scale model of the flood.